Section 3.2, we're going to focus on isosceles and equilateral triangles. Let's start by recalling that an isosceles triangle has at least two congruent sides. Those congruent sides are called the legs, and the vertex angle is the angle that is formed by the legs. The side across from the vertex is called the base, and the base angles are the two angles that have the base as the side. So for example, in these two pictures here, angle 3 is the vertex angle, and angle 1 and angle 2 are your base angles. Okay, the red lines represent the base in each triangle, and the black lines represent the legs. Okay, here we have the isosceles triangle theorem and its converse. Basically, it was saying if you know a triangle is isosceles, not only are two sides congruent, but then we can also show that two angles are congruent. So in this triangle, if these two sides are congruent, the angles that are across from them are also congruent. So angle C is congruent to angle B. And the opposite of that is also true. If two angles are congruent, then the sides across from them are also congruent. So side DF is congruent to side DE. So we basically call these if sides then angles, or if angles then sides. That's how we call these theorems, what we call these theorems. So let's take a look at a couple. Example 1 says find the value of x. Because these two are congruent, I also know that these two angles are congruent. So I can call this angle C x. So then 38 plus x must add up to 180 because that's how many degrees are in a triangle. Combine like terms. Subtract 38 and divide by 2. We get x is 71 degrees. All right, here we have congruent angle markings, which means the sides across from them are also congruent. So I know these two sides are equal. Forget about the 5x plus 2, it doesn't mean anything. But I know 2x plus 6 must equal 8x minus 18. Subtracting 2x from both sides. Adding 18 to both sides. And divided by 6, we get our answer of x is equal to 4. Next question says QRS is isosceles with base QR. That's important. So let's draw our triangle. Try to draw it so it's isosceles. And the base is QR. So let's mark up two sides congruent. QR would then be down here, which makes S the vertex angle. QR is 6x minus 3, QS is 9x minus 1, and RS is 8x plus 7. Ignore this for now. It doesn't mean anything yet, because we know these two sides must be equal. So I set 9x minus 1 equal to 8x plus 7. Subtracting 8x from both sides and adding 1 to both sides gives us x equals 8. Now the question says to find all sides. So put that 8 back into all three sides. We should get 71, 71, and 45. Number 3 says find the value of y. Because these two sides are congruent, I then know these two angles must also be congruent. So I can set 6y equal to 8y minus 16. Subtracting 8y. And divided by negative 2 gives me y equals 8. Number 4, we can see that these two angles here are the same. They're both 77 degrees, which means the sides across from them are also the same. So I can set 10x plus 31 equal to 15x plus 16, ignoring the 2x for now. Subtracting 10x from both sides, and subtracting 16 from both sides, and dividing by 5 gives me x equals 3. And that's all we're looking for in this problem, so you could stop there at x equals 3. Number 5, because these two sides are congruent, these two angles must be congruent. So that angle B is 42. So then I can say x plus 42 must equal 180 degrees. Or x plus 84 must equal 180 degrees. So x equals 96. All right, now we're going to talk about equilateral triangles. It's pretty much the same thing, okay? But an equilateral is 3 congruent sides. So if all 3 sides are equal, that tells me that all 3 angles must also be equal. And the second one's just going backwards. If all 3 angles are equal, that means that all 3 sides must be equal. So here's a couple problems here. Number 6, we see all 3 sides are equal. That means all 3 angles are equal. Okay, and more specifically, since the angles must add up to 180, all 3 angles must be 60. That's true for every equilateral triangle. The angles must always be 60 degrees. So I can set 3x plus 5 equal to 60. Subtract 5. And divide by 3. Now this is not a whole number, so I'm just going to leave it as 55 over 3. Part B, since all 3 angles are congruent, that means all 3 sides are also congruent. So I can set 2t plus 1 equal to 4t minus 8. Subtracting 2t and adding 8 and dividing by 2. You get t equals 9/2, or 4.5. Same thing for C. Since all 3 angles are equal, that means all 3 sides are equal as well. Subtract 4y and add 6. And then for D, all 3 sides are equal, so that means all 3 angles are equal, and we talked about in part A that all 3 angles must equal 60. So I can set this equal to 60. Subtract 32 and divide by 2. So last one here says find the value of x and y and segment US. All right, so first of all, I know these 2 angles are equal. So therefore, I know these 2 sides are equal. So I can then set y minus 2 equal to 9. Add 2 and I get y equals 11. All right, that's my first of 3 things I need to find. Right here, I know this is a linear pair. So 180 minus 50 is 130. And then if I do 180 minus 30 minus 130, I get this angle here is 20. If I add these two together, I get this big angle here is 80, which means this big triangle must be isosceles because I have two angles that are 80. 80 and 80. So that means this side and this side must be equal. So 3x minus 15 must equal 12. I'm sorry, not 12. The whole side, which is 21. Add the 15 over and divide by 3. We get x equals 12. And that is our second answer. The final thing tells us to find the measure of US, which is in the middle here. US is just half of x. So US is 0.5 times 12. US must be 6. And that'll do it for section 3.2.